Hello, and welcome to episode 2 of the Zwicky Chemical Factory. I am your host, Adam Miller, and today I will be going through a few classifications on the project. We'll just randomly see some spectra that pop up on the Zwicky Chemical Factory, and I will talk through the process that I use in order to classify those spectra. And who knows, maybe we'll get lucky and see some very fascinating features. If you want to navigate to the project, as a reminder, you can go to our short URL, which is zwicky.tf/loo. Zwicky.tf/loo. And once there, let's just jump right into the classifications. Okay, here we have what looks like a really great match right off the bat. There's very strong P Cygni profiles for calcium, which is what's this big feature here between 9,000 and 8,000 angstroms. And then we have a lot of other sort of what is looking like a spectrum that's getting towards moving into the nebular phase. Let's see what the other matches look like for this source. But number one looks really good. We're essentially matching all of the emission and all of the absorption as we otherwise might expect. Match number 2, that looks a little bit better, but those are very similar to be quite honest. Match number 3, maybe just a touch worse. Match number 4, also a really good match. And match number 5, that also looks like a pretty good match to me, although there is this one feature here that isn't matched so well at about 7,500 angstroms, and I think that was matched decently well in some of the other spectra. So I think I'll avoid match number 5. I'm sort of back and forth between 1 and 3. And to be frank, you could go with just about anything here. But I think number 3 looks just a bit better. It matches this feature here a little bit more closely than number 1 does. So I'm going to select number 3, and we'll move on from that source. Okay, here we have, again, we see some calcium here between 8,000 and 9,000 angstroms. But the remaining features are a little bit hard to identify, although there is something weak happening here and a feature here and a feature here. So 2B maybe is not a bad choice, although this also looks like it could maybe be a type 1B supernova because I don't see very strong evidence for hydrogen, which you would normally expect at about 6,500 angstroms. I just don't really see that emission or absorption. So here's another example of a 2B, and we see some of the lines do line up pretty well, but the hydrogen feature that's right here in this 2B isn't really matched at all. So I'm not sure that that's a good match. Here's a 1991T type 1A supernova, and in this case, this just doesn't look like a very good match to me. The calcium profile is very different from what's been observed, and there's a lot of absorption. And then this emission feature in the spectrum sort of lines up with this emission feature here, but these narrow lines, I strongly suspect, are from the host galaxy. And one way you can tell that is that we also see some sulfur emission here to the right of the strong hydrogen emission. So I don't think that that's a 91T. Here's another match to a 2B. And our final match is to a type 1C norm. I actually think that of all the matches that this one is the best because the strong hydrogen feature is just simply not present in all of the 2B spectra that are there. So I'm going to go with number 5. Say this is a 1C. All right, here we have a pretty noisy spectrum. These are often cases where it's somewhat difficult to find a good match. I also see something that I sort of flag as being unlikely, not impossible, but unlikely. The rest frame wavelength that's being displayed for this particular match goes from 2,000 to 6,000 angstroms. So that means that the redshift assumed by our algorithm is very high. And in fact, it's so high it's at 0.478. While it is technically possible for the Zwicky transient facility to find a supernova at a redshift of as high as almost 0.5, it's actually incredibly likely. So I think this is a bad match for that reason. We'll see if all the other matches also share that characteristic. Okay, so this is also a very high redshift match. Here's another high redshift match. Here's another very high redshift match. And yet another very high redshift match. So I'm not sure any of these are actually correct, but I'm going to try to pick what I think is the best match here. I think there's a lot of absorption features in these 1A spectra that do not line up particularly well. This 1C broad line I also don't think lines up very well. I think for me, this 1B normal is the one that matches the best, although again, I don't think that this is necessarily the correct answer. But I'm looking for the best match of the 5 spectra provided, so I'm going to pick number 5 in this case. Okay, next we have a spectrum that has very strong and moderately broad emission lines. So we have this here is hydrogen called the H alpha line at about 6,500 angstroms. We also see the H beta line here at 4,800, and then there's strong oxygen emission here at 5,000 as well. These are all strong characteristics of an active galactic nucleus. So this very much seems like an active galactic nucleus, and as such, I think this is a very good match, template number 1. We'll take a look at the others. So a QSO is essentially also an active galactic nucleus, or AGN. It's just a little bit more luminous. That's also a pretty good match. This galaxy spectrum provides a pretty good match. Here we have another galaxy spectrum that provides a decent match. And finally, here's a spectrum of a type 2. And I don't think that that type 2 spectrum actually lines up particularly well. I think that this is an AGN, and I think that match number 1 is the best of the ones that we have looked at here. Okay, great. This is a fun one. So here we have a very clear type 2 supernova. And we know that this is clearly a type 2 supernova because we have very strong P Cygni profile of hydrogen alpha here at 6,500. We also see H beta here as well. And then there's some clear, a nice small P Cygni profile that's lining up pretty well here at about 5,700 angstroms. So this looks very much like a normal type 2 supernova to me. I don't see any strong helium absorption, so there's no reason to think that this might be a type 2b. All right, so here's another match to a 2 norm. I think the first one looks better. The P Cygni absorption is just moderately weak in this supernova. So here's a match to an AGN. That actually looks somewhat decent, although the emission line at hydrogen is narrower than the profile that we see, and there isn't really any evidence for the oxygen emission at 5,000 angstroms that you would otherwise typically see in an AGN. So I'm not sure that that's a great match, not a bad match, but not a great one. Tidal disruption event, that also looks decent, but I think the profiles don't line up quite in the way that you might expect. There's also a significant absorption here at about 3,900 angstroms or so. Typically that's due to calcium, and I just don't see any sort of evidence from the tidal disruption event to match that. And then we have a match to another type 2 normal event, and again, that looks pretty good relative to the actual spectrum here. I think number 1 is the best match. The shape of the sort of absorption features is really well tuned relative to the spectrum that's been observed. So I'm going to go with match 1 in this case. Oof. Okay. That doesn't look good at all. And this is something, as I've covered in previous tutorials, this is something that can happen. The algorithm sometimes does not identify very good matches. I think part of what might be happening in this case is that there's some strong emission. This looks like strong hydrogen emission, possibly from the host galaxy, and that might be throwing off the algorithm as it tries to fit that, assuming that it maybe is the result of some other feature. But this does not look like a type 1a normal supernova, at least relative to the template spectrum that's shown here. And that corresponds to our second best match and our third best match. Again, I don't think that these are particularly good matches. Just the strength of the silicon absorption here is just completely different from what's actually in the observed spectrum. Here we have a match to a type 1c normal. That actually doesn't look too terrible, although this complex, whatever this emission complex is in the 1c, does not match what we're actually observing here. And I think that's because this emission is due to hydrogen, probably or possibly from the host galaxy of this supernova. And then here's a 1cBl. I think that this is a case where we don't have any good matches. I'm not sure that I would say that any of these spectra provide a good match, any of these templates provide a good match to the newly observed data. So I'm going to select no good match and move on to our fifth and final spectrum for today, which, oh wow, okay, so this is a pretty good match to a type 1c broadline supernova. These are very rare supernovae. They are not particularly common. And the distinguishing feature in a broadline type 1c supernova is that the ejecta are moving extremely fast following this explosion. And so you can see that with extremely broad lines, broad absorption lines, I should say, in the spectrum of the supernova. I actually think this looks like a pretty good match. We should check the other ones and see if we see anything that looks a bit better. But that one doesn't look so bad. Okay, so here's a type 1b normal supernova, and that one also has a lot of features that seem to line up decently well. So that may be tough to decide between those two. Let's check the match redshift. So the match redshift is pretty high, 0.22. ZTF can find supernovae at redshifts that high, but it is not common, I would say. It is not common to have redshifts that high. Here's a match to a type 1b norm at that high redshift. Okay, here's another match to a type 1c. Again, this is a pretty high redshift, but we do have features that line up decently well. And yet another match to a type 1c. This one, the main feature is matched pretty well by this particular spectrum, but it just seems as though the what's going on, whatever's happening over here is not being matched particularly well. So I'm not sure that number 5 is a good match here. I will quickly note the smoothness that you see both in the very blue portion of the spectrum and in the red portion of the spectrum beyond 7,000 angstroms. That is actually not indicative of the data in the template. That is just a result of the fact that this template spectrum came from a spectrograph that is not able to detect light that is at wavelengths greater than 7,000 angstroms and at wavelengths less than about 3,800 angstroms or so. And so the software has just automatically assumed smooth evolution or smooth behavior in those regions. So this is a tough one. I think that of all of the examples that I have looked at here, I mean, this 1B norm, that matches pretty well. And so I think that may be what's the best. We also have the normal 1Cs and the broadline 1C. I think the best match here is actually number 2, the type 1B normal. Again, I'm not sure that this is necessarily absolutely correct because the inferred redshift in this case is quite high, but I think that the 1B normal is the best match, so that's what we will go with. Okay, so that concludes episode 2 of the Zwicky Chemical Factory. We hope you enjoyed today's video and that you like working on the project. We look forward to seeing you in future episodes. Until the next star explodes,